The prevailing method for building multi-agent systems relies on chaining large language models together, passing massive prompts between nodes as data volumes grow. This approach triggers context collapse. As agents interact, they accumulate massive logs of tool outputs and intermediate reasoning steps that eventually bury the underlying instructions. Without a rigid external harness, these systems also fall into runaway execution, infinite loops where unmonitored agents execute broken code repeatedly while exhausting API credits. MilimoClaw treats agents as volatile software processes rather than conversational partners. It is an open-source multi-agent hustle mesh built on the NVIDIA MilimoClaw runtime. The platform's name comes from Milimo, a Zambian Tonga word meaning works, tasks, or labor, reflecting a utilitarian design philosophy. Because context collapse and runaway loops are inherent to unbounded LLM interactions, stable swarms require aggressive physical bounding and strict systems engineering. To achieve this stability, the architecture utilizes three specific pillars, starting with kernel-level zero-trust sandboxing. The second pillar involves stateful process supervision and out-of-band orchestration to maintain system health. Finally, the system employs native context compaction to enforce hard memory limits. The challenge of 24/7 startup-scale autonomy is a matter of infrastructure and containment. Granting autonomous code unfettered access to a file system introduces the risk of a single hallucinated command, deleting system directories or overwriting production files. MilimoClaw mitigates this by splitting the workload across 6 distinct autonomous claws, assigning specialized roles like content, operations, and build to separate processes. This schematic shows 6 distinct nodes. Rigid boundaries prevent traversing sibling file systems. Kernel-level protections confine agents to specific directories. 2 profiles deploy, OpenClaw for solo operators and Hermes for headless servers. Zero-trust boundaries trap compromised agents, completely protecting the host machine. Physically blocking all 6 autonomous claws from sharing files requires a highly secure mechanism to coordinate their complex workflows. The open shell gateway routes communication via typed contracts. The assistant claw, Lucy, manages task routing. To prevent silent stalls, Lucy actively pulls isolated pathways. Upon detecting timed-out milestones, she injects a hold alert into the operator's war room, ensuring predictable pipeline supervision. Infinite execution loops eventually crash against the maximum token boundaries established by API providers. The system locks the context window at 64,000 tokens. Context pruning strips non-essential outputs. Hitting the 4096 token buffer triggers safeguard compaction to synthesize the current state. This summary is flushed to a physical sol.md file, resetting the context while preserving operational memory. Actuation introduces immediate physical risk, safely allowing autonomous agents to spend real money or provision cloud infrastructure requires specialized protocols. The Finance Claw handles these tasks through an integration with the Stripe Link command line interface. A strict double-gate authorization protocol secures financial transactions. Stage 1 traps agent spend requests in a war room hold state. Releasing this hold triggers a push notification. The transaction only completes via explicit biometric approval in the operator's Stripe app, safely reserving authorization for humans. Managing a multi-agent mesh requires human operators and new agents to have immediate access to the current state of the network. This visualization shows the structure of the Milimo Knowledge Vault, an Obsidian-ready Markdown directory that acts as the system's absolute ground truth. The vault uses the LLM wiki pattern, featuring strict metadata schemas and tags, allowing models to absorb the entire system context in seconds. It includes self-evolution logs, where the claws document their own progress. Every Sunday, they write, backtest, and register new Python tools to expand their capabilities. This self-documenting environment prevents the instability common in standard chained LLM deployments. MilimoClaw treats large language models as untrusted microservices. This approach requires exact containment, isolation by kernels, active stall monitoring, and hard memory limits. The power of an autonomous platform resides in the infrastructure that orchestrates the mesh. In this model, your friend group is a startup, your hardware is the infrastructure, and your multi-agent claws do the work.